Thunder has a strange reputation. It never appears alone, never arrives quietly, and never asks for permission. One moment, the sky is calm, and the next, a deep rumble rolls across the horizon as if the clouds themselves are speaking in a language older than humans. For thousands of years, people believed thunder and lightning were messages from gods. Some thought they were signs of anger, others saw them as warnings, or even punishments sent from above. And honestly, if you hear thunder shaking your windows in the middle of the night, it is very easy to understand why. But tonight, instead of myths and fear, we are going to look at thunder and lightning through science. Not complicated equations, not heavy terminology, just a calm explanation of what is actually happening above your head when the sky suddenly decides to be dramatic. Before we begin, if you enjoy science explained like a story rather than a lecture, remember to like the video and subscribe to the channel. It helps us keep turning powerful natural phenomena into something you can understand, relax with, and maybe even fall asleep to. Now here's the surprising part. Lightning is not just bright light. Thunder is not just loud noise. Together, they are the result of one of the most extreme natural events happening regularly in Earth's atmosphere. Something so hot that it briefly becomes hotter than the surface of the sun, and yet lasts for less than a second. So take a deep breath, imagine a storm slowly forming in the distance, and let us uncover what thunder and lightning really are, and why the sky sounds like it is tearing itself apart. To understand lightning, we need to start inside a storm cloud. Thunderstorms are tall, powerful clouds that stretch many kilometers into the sky. Inside them, strong air currents push water droplets and ice particles up and down at high speeds. And when particles collide, something familiar happens. Electric charge builds up. Lighter ice crystals tend to gain positive charge and move upward. Heavier particles gain negative charge and sink toward the bottom of the cloud. Over time, the cloud becomes electrically divided, like a giant battery floating in the sky. Nature, as you might expect, does not enjoy imbalance. So eventually, the electricity looks for a way to escape. That escape is lightning. Lightning is a massive electrical discharge that happens when the difference in electric charge becomes too large to contain. It can travel from cloud to cloud, within a cloud, or from cloud to ground. And when it strikes, it does not gently pass through the air. It violently forces its way through it. Here's where things get intense. Air is normally an excellent insulator, meaning electricity cannot easily pass through it. But lightning changes that in an instant. The electrical discharge superheats the air around it, ripping electrons from atoms and turning the air into plasma, the same state of matter found in stars. The temperature inside a lightning bolt can reach around 30,000 degrees Celsius, or 54,000 degrees Fahrenheit. That is about 5 times hotter than the surface of the sun. Fortunately, this extreme heat exists for only a fraction of a second, otherwise thunderstorms would be much more inconvenient for life on Earth. Now let us talk about thunder. Thunder is not caused by clouds colliding or gods bowling in the sky. Thunder is simply the sound of air reacting to lightning. When lightning superheats the air expands explosively. Then it cools just as fast and collapses. This rapid expansion and contraction creates a powerful shock wave, which we hear as thunder. The reason thunder sometimes sounds sharp and loud, and other times deep and rolling, depends on distance, terrain, and how the sound waves bounce through the atmosphere. So thunder is not one sound. It is the echo of a violent moment stretching across space. A fun detail. Lightning and thunder happen at the same time. We see lightning first only because light travels much faster than sound. This is why counting seconds between lightning and thunder works. Every 3 seconds roughly equals 1 kilometer of distance. Nature, once again, gives us a free measuring tool. Despite its power, lightning is surprisingly brief. A single lightning strike lasts only milliseconds. Yet in that moment, it can split trees, melt sand into glass, and remind humans how small they are compared to atmospheric physics. And still, thunderstorms are not acts of destruction. They play a role in balancing Earth's electrical system and even help fix nitrogen in the atmosphere, contributing to soil fertility. Lightning is dangerous, yes. But it is also part of how the planet functions. Thunder and lightning are reminders. Not reminders of fear, but of scale. They show us that above our quiet lives, powerful processes are constantly unfolding. Processes that do not care about human schedules, buildings, or worries. And yet, most of the time, they pass without harm. Storms come. Storms go, and the sky resets itself. Understanding thunder and lightning does not make them weaker. It makes them less mysterious, and strangely, more beautiful. Because when you realize that a flash of lightning is the air briefly becoming as hot as a star, and thunder is simply the atmosphere adjusting to that moment, the fear fades into respect. So the next time you hear thunder rolling across the night sky, remember that it is not anger, not punishment, and not chaos. It is physics, doing its job. Thank you for spending this quiet moment learning with us. If you enjoyed this story, like the video, subscribe to the channel, and join us again for more calm science before sleep. Now let the storm pass in your imagination, let your thoughts slow down, and rest. Good night, and sleep well.